Hello there, Mr. Sutton here, bringing you the Algebra 2 5-4 Part 1 homework solutions on solving radical equations. To start this problem off, we're going to try to isolate this radical term. So first thing I'll do is subtract 13 from both sides. That'll give me negative 24 over there. And then let me divide by negative 2 to get this radical by itself. So we have radical 24x equals 12. To get rid of the radical, we're going to raise both sides to the index. Since this is a square root, we're going to square both sides. That leaves us with 24x equals whatever 12 squared is. I believe that's 144. And then dividing both sides by 24, we end up with x equals 6. Now we just have to check and make sure that actually works. So plugging this back into the original, we have square root of 24 times 6, so that's the square root of 144. And then the square root of 144 is 12. Negative 2 times 12 gives us negative 24. And negative 24 plus 13 gives us negative 11. So that works out, and 6 is actually the answer. To solve this radical equation, we already have the radical expression by itself, so we can raise both sides to the index. In this case, that's 3, so we're going to cube both sides of this equation. That leaves us with x minus 16 and 2 to the third, which is 8. And then we just quickly add 16 over to the other side, and x equals 24. But let's plug that back in just to make sure. So we have 24 minus 16 in the cube root, and we're asking, does that equal 2? Well, this is the cube root of 8. And the cube root of 8 is, in fact, 2. So 24 is the answer. On this one, we're trying to solve this cube root equation. We'll start by isolating the radical here. So let me add 15 to the other side. That's going to be 32 over there. And then dividing both sides by 8 gives us 4. Since we've got the radical by itself, let's raise both sides to the third power to undo the third root. That leaves us with 10x equals 4 to the third, which is 64. And then we just need to divide both sides by 10. So we can call this 64 over 10. If you want, we can reduce this to 32 over 5. But let's now check our answer and make sure this actually works. So when I plug this back in, I'm going to be a little bit crafty, and I'm going to plug in 64 over 10. And you're going to see why I'm using that instead of 32 over 5. I mean, either one will work. But if I plug in 64 over 10, these 10s here are going to cancel out really nicely, leaving me with the square root of 64. The square root of 64 is 8, or actually this is the cube root of 64, I should say. The cube root of 64 is 4. 8 times 4 is 32. And then 32 minus 15 does give us 17, so this one works. 32 over 5 then is our final answer. For this problem, since we have one radical on each side, we can immediately raise both sides to the index, which is the second power. So squaring both sides, basically getting rid of the square roots, we just end up with 4x plus 1 equals x plus 10. And then I can subtract x over to the left, giving me a 3x over there. Subtracting 1 over to the right gives me a 9. And dividing by 3 gives me 3 for my answer. But let's plug it in and make sure it actually works. So we have 4 times 3 plus 1, square root of that. And also 3 plus 10, square root of that. This is going to be the square root of 13 on the left and the square root of 13 on the right. Since those are the same thing, that means that 3 is our answer. To tackle this problem with these two cube roots, we're going to get exactly one cube root on each side of the equation. So I'm just going to add this cube root of 8x plus 1 over to the right side. And now, once I've done that, I can cube both sides of this to get rid of the cube root. So that's going to be 2x minus 5 equals 8x plus 1. And now let me move the x's over to the left. I guess it doesn't really matter, but 2x minus 8x, that'll be a negative 6x over there. Let me move 5 over to the right. Adding 5 over there gives me a 6. Dividing by negative 6 gives me x equals negative 1. Now let me plug this back into the original. So I've got cube root of 2 times negative 1 minus 5. Minus cube root of 8 times negative 1 plus 1. So we have negative 2 minus 5. That's going to be negative 7 in that cube root. Over here, this is negative 8 plus 1, which is also negative 7 inside the cube root. If I take the cube root of negative 7, whatever that is, and subtract it from itself, that's going to end up being 0. So we do end up with 0 equals 0, which confirms that negative 1 is our answer.